Hey guys, today I want to present a solution to the India EGMO TST 2023 problem 4. At first, let's have a look on the problem statement. We have two functions f and g from the reals to the reals, such that f of g of x plus y is equal to g of x plus y. Now we have to prove that either f is the identity function or g is periodic. The first thing we notice is that the right hand side is symmetric in the variables. So we can switch x and y and the right hand side stays the same, but on the left hand side we get a new term. So let's have a look what exactly this tells us. We have that f of g of x plus y is equal to g of x plus y, but this is now also equal to f of g of y plus x. It would be nice if our function f is injective, because then we can directly follow from this equation here that the two arguments here are equal. Therefore, we want to consider at first this case, that f is injective. As I said, this now tells us that the two arguments here are equal, so we conclude that g of x plus y is equal to g of y plus x. And now, in order to find a term for g of x, it's a good idea to plug in y equals 0 to conclude that g of x is equal to g of 0 plus x. We plug this into our functional equation to get that f of x plus y plus g of 0 is equal to x plus y plus g of 0. Here we can plug in y equals minus g of 0 to conclude that f of x is equal to x, and therefore in this case f of x must be the identity function. Let's go on with our second case, and in this case we have that f is not injective, and therefore we know that there exists a not equal to b, such that f of a is equal to f of b. To use this information here, we want to have the argument on our left hand side to be equal to a or b, and therefore our idea is to plug in y equals a minus g of x or y equals b minus g of x. So let's do this, and we have that g of x, now we plug in y equals a minus g of x, so plus a minus g of x. This is now equal to f of a. Now we can use this equation here to get that this is equal to f of b, and now we can use again our functional equation from above to get that this is equal to g of x plus b minus g of x. We see that since a is not equal to b, these two arguments here can't be the same, and therefore g is also not injective. So we know that we find some a prime which is not equal to some b prime, such that g of a prime is equal to g of b prime. This implies that we can plug in a prime or b prime into our functional equation here, and the left hand side stays the same. So we get that g of a prime plus y is equal to f of g of a prime plus y, and now this is equal to f of g of b prime plus y, and now we use the functional equation again to conclude that this is equal to g of b prime plus y. By plugging in y equals to x minus a prime, we get that the left hand side is g of x, and on the right hand side we have g of x plus b prime minus a prime. Since b prime is not equal to a prime, this term here is not equal to 0, and therefore this equation here is exactly the definition that g is periodic with period b prime minus a prime. And therefore we are also done in this case, and therefore we are done in total.